Okay, so we all know there's this big controversy about whether the Patriots deflated their footballs in the championship game against the Colts. So I read a bunch of the math that's been posted and looked at the temperatures of the game time, and it all seems to make a lot of sense to me. But it seems like most of the sports writers out there, and most of the public don't seem to grasp what it means when people talk about PSI and how that can change with temperature and weather. So I went out and I bought this thing, which is a little sports pressure gauge. It looks a lot like a car pressure gauge, except it's calibrated to have units that are sort of like football PSI. And it came with this little needle. And I have this football, which I think is a regulation football. Interestingly enough, I was actually at the Super Bowl a few years ago, and this football was a Super Bowl football. And because it was in Miami and I was there, it was actually signed by Don Shula, who recently has been known for calling out Coach Belichick as Belichick. So it would be interestingly ironic if the Don Shula football can help us explain what happened with Deflategate. So, first of all, let's see. We've got the PSI, we've got the football. Let's go just check real quick. Temperature in the house is right now, I think you can see, 73 degrees. I had to warm it up a little bit, but I'm assuming that this is sort of what the temperature was inside Gillette Stadium in the heated room, if that's where they inflated the balls and prepared them for the game. So we've blown up this ball. 73 degrees, and I inflated it to, here we go. I don't know if you can tell, but that is just about 12.5 psi. The bigger tick marks are half units, and the little ones next to the numbers are 12. So that's just about 12.5 psi at 73 degrees. Oh yeah, it's a little difficult to get out. So there's our football, 73 degrees. The referees have measured it. Said, yep, it's 12.5 psi. That's a good ball for the game. Go ahead and use it. The Patriots ball boys then take this football and bring it outside, which we're going to represent the outside by the refrigerator here. So the refrigerator is at 40 degrees for the bottom drawer. It's the right-hand number. Again, the game temperature was probably like 48 degrees. That's what people say. But there was rain and wind chill, so this is obviously a little bit colder, not a lot colder. Basically, we're going from 73 degrees to 43 degrees. Oh, wait, here's a little PSI meter. So that's in the drawer there, and we'll take a look at the time on the microwave here. It's 2:07, and we're gonna wait here for a bit, and just wait. So there's the football, there's the PSI gauge, there's the microwave, and we're going to let that ball cool down to roughly what the outside temperature was at the time of kickoff, and we're going to see what happens. So the math says that when you have a temperature drop of around 30 degrees or so, football that's inflated to 12.5 psi should lose a couple of pounds, slightly less than a couple pounds a square inch of pressure just by being in a colder environment. That's the gas law. And what we want to do is test it, because it seems a little counterintuitive that you get such a big percentage drop in pressure. It seems like, 12.5 to 11, or 13 to 11, which is 2, is something like 2 psi is something like 16%. That seems like a big drop in pressure. Couple things to realize. Obviously, the temperature that we're talking about is going from inside temperature of 73 degrees down to something in the neighborhood of 50 degrees. That's a 33% drop in temperature. If you want to use that same kind of ratio. Now, those are actually the wrong percentages to use because you're supposed to use absolute pressure and you're supposed to use absolute temperature. And so instead, if you go through and do all the math, you should expect to see a drop of around 1.5 to 2 psi on a football just due to temperature change alone. But that seems a little counterintuitive, so we're going to see what happens if that actually takes place. You guys are probably going to want to fast forward at some point because I'm going to leave it in there for 10 minutes or so to let it calm down. Remember, the game balls in question were actually outdoors for probably a couple of hours, maybe. After the referees measured them, they get brought out by the ball boys. Then they're also played with for a half of football, so that's maybe 3 hours or something like that. Certainly, plenty of time to get that temperature down to the 48 degrees in question. Another thing to note is, while we're sort of going through this, is that the feel of the ball, it feels at 12.5 pounds of pressure. Again, you can do your own experiments with this, but the ball actually feels, to me, surprisingly firm at 12.5. So that was a little bit of a surprise. I didn't expect that. It certainly felt harder than I thought it should be, but that's what it is. So by now the balls have been brought outside. They have been sitting there for a while. They have been played with for some portion of the game, and then the Indianapolis Colts intercept one of them. DeQuell Jackson brings it over the sideline, hands it to the equipment official over there, and the equipment official seems to think the ball might be underinflated by feel or something. And basically says, apparently the narrative goes, he says to the coach, "Hey, this ball feels underinflated." At which point the coach doesn't say, "Yeah, that's interesting, but I got to worry about winning the football game." The coach says, "Oh, the ball's underinflated, so maybe someone tampered with it." The coach then, instead of dismissing it, calls up to the general manager and says, "Hey, I know we're losing the football game, but I think I know why. It's because this ball may be underinflated." So general manager, rather than saying, "Yeah, can you get back to trying to win the football game?" instead says, "Oh, they must have intentionally deflated the football at some point to give themselves this unfair competitive advantage, which is why we're losing this game." He then complains to the NFL director of operations or something like that, that there's a problem with the footballs, at which point the director of operations says, doesn't say, "Oh, you really think the football's the problem?" He says, "Oh, I'll have the referees look into it." So somehow they inspect these footballs at halftime and measure them after they've been outside for a while, and they think that they're underinflated. So we have not actually had that much time elapse, unfortunately. We're still okay. Still waiting for something interesting to happen. So we basically have the referees taking measurement of a cold football that was inflated in a warm environment. With a 25 or 30 degree difference potentially in the temperature at which the ball was inflated in, the temperature of the gas going into the ball, versus the temperature that gas has now attained, including wind chill. Obviously, a wet ball in a windy environment will give up energy. So we care about the actual, absolute temperature of the gas inside the ball, and we don't know if we're going to be surprised if there's a 1.5 or 2 pound drop in PSI. We don't know if we're going to be surprised if somebody calls that 15% or if it's actually more like the 6 or 7% that you would call it if you were using absolute pressures. So anyway, this is going to be boring for a little bit. You can fast forward to the point where we take the football out. That'll probably be in another, I'll give another 10 minutes maybe. And then we'll see what happens. So stay tuned. Excuse me. Okay, so that's about 15 minutes or 20 minutes or so since we put that ball in. And I don't think it's gotten down to 40 degrees yet. That's my guess. I could leave it in longer to see more of a pressure drop, but I'm getting a little bored. So we're just going to go ahead and measure this football. Now remember, look, this thing has been played with, outside at this point for 3 hours. We've only had about 15 or 20 minutes of exposure to cold temperatures, but it would have been at 48, 49 degrees for 3 hours. And the refs would go ahead and take this ball back into the dressing room, I guess, and measure it. So let's pull it out of here. Now, one thing to note, this thing does not feel, again, I'm not an equipment manager or anything like that, or a professional quarterback or anything, but this football does not feel significantly softer than it did before when it was at 12.5 psi. It feels a little colder, but it doesn't feel softer. Certainly if you gave me this ball and the other ball, this ball and this ball earlier, those different PSIs, I wouldn't be able to tell a difference. You can see when I put in this thing that this thing is measuring just a tiny bit under 10.5 psi. That is with roughly 15 minutes of exposure to 40-degree temperature. I don't know that it got all the way down to 40 degrees. I'll do it again so you guys can see. Same ball, as predicted, 10.5 psi down from 12.5 psi, or a change in psi of 2 psi just due to temperature. Obviously, no tampering or anything like that involved, just physics. So that explains, I think, 90% of the reported facts on this story can be explained by simply weather and not anything nefarious. Although it's amazing to see that this was a pretty easy experiment to run. I'm sure a lot of sports writers have a football and a refrigerator available, but there we go. So the math seems like it's right, at least to a first approximation. I know there's probably some of you jumping up and down right now and saying, well, but the Colts balls weren't underinflated. How do you explain that? I don't know. There hasn't been a lot of reporting on what happened to the Colts balls prior to them being measured by the referee or inspection. But I think what we've shown here is that a relatively small drop in temperature can cause a big change in pressure. So is it likely the Colts balls were perhaps inflated to something closer to 13 or the higher end of the range? Possible. Is it possible that those balls were inflated in a room that was colder, closer to the exit, the visiting team's equipment room? Maybe they inflated them on the field even. I don't know. Certainly if they inflated them on the field, then had them measured, and then played with them and had them measured at halftime, you would expect to see no pressure change between the time they were measured and the time they were remeasured, I guess, at halftime. Finally, I know this may be a way of explaining the mysterious 12th ball that somehow wasn't under pressure. If that ball was originally used in warm-ups outside, and then had its pressure checked, and it was reinflated and brought up to the proper pressure at the time, then when you remeasure that specific ball at halftime, it will show as not underinflated. It'll show as the correct pressure. So again, I know that there's a lot of discrepancies here. I'm not trying to be exact. It's not, the temperature that, I don't know what temperature the balls were initially inflated under. I don't know what the exact temperature was when they remeasured them. I do know, however, that the math says that a 2 psi drop from taking a football indoors to outdoors is within the ballpark of reasonable. And we've just shown that not only does the math say it's true, but it actually happens. So sorry if I've ruined some haters' days, but you know, go Pats. Bye.